Okay, so for the previous lecture, uh, if you notice that in your table TF-IDF tu satu kolom tu no ataupun satu row tu satu term kan, tapi in some cases, in most cases, some of the term come together like software engineering, ICT, information communication technology. So if we split them into one single term, so we lost the connection. So this chapter, this is called set base, alternative set base, in which we group the term into 2 gram ataupun 3 gram, meaning that two terms come together or three terms come together lah. Okay, so that's why they call it set base term. Let me share the slide. Okay, so this one is more or less the same with what you have studied before, but this one they cover more terms lah, more than one. Okay, so boleh nampak the modeling part 2, alternative set base.
Boleh.
Okay, so this one, let me arrange. Okay, so this is called set base model. Set base model because they call it set because we have more than one term to be considered. Okay, so what we look at here is that we look at the term dependency. Okay, we look at more than one term that maybe have something to do with another term. So this is term dependency that capture through term set. So this is set of terms lah, which are set of correlated terms. Okay, the approach which leads to improved result with various collection. So this one will have more flexible in terms that you can search for two terms now, not only for a single term. Okay. So to define the term set is a concept used in place of index term. So this is for single index term. Okay, but the term set here referring to a set of terms. So that's why we use S here, because it represents sets. So it could have a number of key here, keyword ataupun term is a subset of the terms in the collection. Okay, so given the combination of term that we have here, we could have many sets. Okay, so if all index term in the term set occur in document J, then we say that the term set Si occur in Bj. So if all of these term if we say that this term set exists in document J, that means all these keyword exists in document J. Okay, so since we could have a few combination depending on the number of unique keyword that we have, so we have this possible 2 to the power of t, where t is the number of unique term that you have in your vocabulary. So we have this number of combination. Okay, so where t is the vocabulary size. So for example, if you have this keyword K1, K2, K3, so the number of item that you get, the number of term set will be 8, because we have 3 unique keyword, and then these are the possible keyword that we could have. The possible term set. Okay, so you could have empty set or individual or combination of two terms, and then lastly combination of 3 terms. So altogether we have 8. Okay. So these are the now we are considering this term set, which each one of them is represented by a set of keywords. Okay. Okay. So for example, let T be the number of terms of the collection. So T is the size of your vocabulary. And then we could have a set VS. This is set of um, term set that we could have. So we could have up to this number of combination. Remember that if our T is 3, so that means we have S1 until S8. Okay? But if our T is 4, then we have S1 until S16. The possible number of term set, okay, the possible combination of term set that you could have. Okay? So to illustrate, consider this document that we used last time. Okay, so we have document 1, document 2, and document 3, 4. Okay, let's simplify the notation. So for each of the keyword, we use A, B, C. And then when we transform them into a single symbol here, this is what we get. Okay. Okay. Let's suppose we are looking at this query. Okay, we have query Q, and our query is to do be it. So when we transform them into the symbol, we have A, B, D, N. Okay, so our query consists of 4 terms. So this is considered as one term set. So the possible number of combination will be how many? To the power of 4. So we have 16. So 16 possible combination. And the first one, of course, the empty set we will not consider. So we left with 15 minus this one. Okay. So we start with the individual term first. So we start with A, B, D, N. Okay. And then for each of the set of term here, for example A here, so we want to look at this document, how many number of document that consists A. So in this case, we have 1 and 2. So we write down here. Okay. So if we only use single term B, then we have this number of document. And D, we have 4. And then N, we only have 1. Okay. And then now we will continue with the combination of this AB, which is this, and then the combination of AD, and then the combination of AN, and then we will continue with B, and then this one, and then finally this one. Okay. So we start with the AB first. So we have AB. So meaning that we want to find document that consists both A and B. So we only can find in document 1. So we list that one. And then we do with AD again, 2 document, and then AN. But AN here, we do not have document that consists both A and N. Okay, so this one only N. So for that reason, we only have 3. Okay, so now we continue with BD, but yeah, we have AB, AD. So there is no AN. Okay, so now we continue with the BD, this one. So we have 2 document, and then BN. we have no. For BD we have 3 documents, and then for BN we only have 1. So if we refer to this, so we only have BN here. So only 1 document. Okay, and then we repeat again for D and N. But for D and N, we do not have D and N here. Oh, here. Yeah, we have this one, D and N, so only 1. D and N, but we did not, no, D and N, what do we have here? D4 here. Where is D and N? Oh, the way we look into this one is that since we do not have DN, where is DN? Let me check. So we have D and N. Why D and N do not? Why we don't have DN here? I think missing here. Okay, let's add that one here in the example. So we have B and N already, B, D already. So now we have D and N. So D and N was to be here. So we have S, D, N, where we have document 4, D and N, kan? So D and N, document 4. Okay. Okay, so we complete with that one. So now we have a combination of 3. So first we do this ABD and also BDN. Okay, we could have ADN also, but ADN we do not have that one in the list. So basically we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this one should be in. So we have 11 term set here. Okay, so out of maximum to the power of 4, which is 16. Okay, so this is how we list the document with respect to the set of term. Okay, so what we want to do is we want to identify all the possible term set that we could have. So in this case, we have 11 term set. So we have to try all the possible combination. Okay. Okay. So once we get this, then we look at what we call frequent. Okay. So since we have so many term set here, we want to look at all the frequent term set only. So depending on our definition, what is the frequent term set? Okay. So the definition of frequent term set is a term set composed of n terms is called the n term set. So, for example, this is one term set. Okay, so this one is 3 term set. Okay, and let ni be the number of document in which si occur. So this is the number of document that we have. So this is NI. Okay, so this one is 2, this is 3, this is 4, and then this is 1, 1, 2, and 3. Okay. Then we say the n term set Si is said to be frequent if the number of documents that consist that term set is greater than or equal to a given threshold. So it depends on the given threshold. So this implies that the n term set is frequent if and only if all of its n minus 1 term set are also frequent also. So we are looking at the frequent term set definition. It depends on the threshold here. Okay, so this frequent term set can be used to reduce the number of term set to consider with long query. So that's why here, let me erase this. So we have 11 term set that we can consider for the query queue here. Okay, but in order to reduce the number of computation, because there are so many here, so let's suppose the threshold is okay. The threshold is 2. So that means this one will not be a frequent term set. So they can be ignored. So we only consider the one that set of term that exists more 2 or more. So this is 2, this is 3, this is 4, 2 and 3. So we only consider A, B, D, AD and BD as frequent term set. So we only carry this in the next computation. Okay, can you follow? So that is the definition of frequent term set here. But we it depends on the threshold given to you. So normally it's all given lah. Okay. So for example, this one, if we say let's suppose the threshold of the frequency of term set be 2. So based on all of this, we only select the one that near. So the first one is this one. This is frequent one term set. So only consists a single one. Okay, and then the next one, two term set. Okay, so this is two term set because we have 2, and then that's all. So there is not frequent 3 term set because for the 3 term set we only have one document each, ABD and BDN. So these are the frequent one term set. Okay, this is frequent one term set. This is frequent 2 term set. Okay, so now how do we compute the ranking? Okay, so notice that there are only 5 frequent term set in our collection, only 5 of them. Okay, so inverted list for frequent n term set can be computed by starting the inverted list of frequent one term set. So um, we start with this one first, the single one. Thus, the only index that is required are the standard inverted list used by any IR. So what they're saying that we will start with this computation for the single term first, then continue with this. But if you look at this one, A and D, they are covered here. Okay, and also B and D, they are covered here. Okay, so meaning that if we remove this, we have A here already, and all of this A, B, D are here already. Okay, so what we want to do is we want to reduce again to a smaller number of frequent term set in which it's cover almost all of the single term or the 2 terms if you have 3 terms lah. Okay, so okay, let's forget about the coverage here. That one we will do in the next step. Okay, but now what we can do if we have this 5 frequent term set, how do we compute the ranking? So the ranking is computed based on this formula, the weightage. So the weightage here. So this is your frequent term set. Okay, and this is the IDF. So this is your TF. This is your IDF. Okay. So when we look at this formula, we look at the set here. So in our example here, we have 5 sets. Okay, so we have 5 sets, S1 until S5. Okay, so N1 referring to number of document in which term set SI occur, N be the total number of document, and this Fij be the frequency of set I in the document DJ. Okay, so we are looking at sets now, not individual term. So here we are referring to how many times the set that we have exists in the document J, and then this is the weightage. Okay, so let's compute the weightage for the I, the set I in Q. Okay, let's take a look at this. Okay, can you see this one? So the first thing that we have to understand is that what is Q and what are the content of the document. So for example, like this, we are looking at the Q, A, B, D, and that is our query. And also we are looking at document 1 only. Okay, document 1 only. And we want to find what is the distance between these two. Okay, so okay, for this calculation, we are looking at all of the document. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is what we missing just now. So now they are here. So okay, so we start with a single one, A. So we we look at the weightage of A, set term A in document 1. So how many times A exists in document 1? Let me remove. So we have 1, 2, 3, 4. So 4 times exists in your document 1. And then log 1. So this one is the total number of document you have divided by total number of document that containing A. So we only have 1 and 2. Okay. And when we compute this one, we get this. So this is the weightage of set term A in document 1. Okay, so we repeat again for B. So B, how many times exists? 1 and 2. So we have 2 here. And then this one are referring to how many number of document consists B only. So we have 1, 2, and 3. So that's why we get 3 here. So don't forget this is log base 2. Okay, so we get this one. So all the single term are straightforward. Let's take a look at AB here. So AB, let me choose different color. So AB. So we have AB in document 1. Okay, so this is AB. So we want to look, okay, 1 time and then 2 times. So that's all. 2 times only. So we cannot reuse. Once we use B, this one, we cannot use that one for another one. So that's why we get 2 only here. And then out of 4, we have only one document that consists AB, which is this. Okay, the rest that, does not contain A, B. So we repeat again for the AD in document 1. So we have 1 and 2. So only 2. And then out of the 4 document, we have 2 document only, which is 1 and 2. Okay, so straightforward. Okay, if we look at the ABD, okay, let me remove some of the highlighter here. So for ABD, we have A, B, and D. So this is considered 1. And then we also have A, D, B. Okay, so we have 2. So we only have 2 here. Okay, so out of all the 4 documents, we only have this. Okay, and when we compute, we get this. Okay, so once we get all the weightage, then we are ready to compute the distance. But this is only the distance between the set term that we have. Okay, remember that this set of term is derived from this query. Okay, and now we want to compute the weightage of this set term with respect to the query again. This is the weightage of the set term for this document. Remember, this is the weightage of term set A for document 1. Okay, so to find the distance between the query and also the document, we use the cosine distance. So this is similar formula, the same formula that we used before. For the term set that are not in the query, we set them to be 0. Okay, now and if you look at this one, this formula, because if you look at the formula here, if you want to find the distance between the queue and all the document, the parameter that changing is only this one. Okay, so when we compute this one, and if you want to compare, we do not have to compute for this because they are constant. Okay, so this one will be changed throughout your calculation because you want to compute D1, D2, D3, and D4. We have 4 documents. So that's why here they said, okay, for the document 1, we will look at the length of the document for individual one. Okay? So we will compute them. So we have all of them here. So we just take that one. We have this. Okay? So A, B, C, D, A, B. Okay, so we have to look at from here. Okay, we did not count for C and D because they are not in the queue, but for the calculation of the document, we have to compute lah. So for the C, for example here, so we have how many document? One only in D1, and then for the D, we have how many? 1, 2, 3, 4. So 4. D1, D2, D3, and D4. Okay, so to compute the weightage, we follow this calculation. So meaning that we will see how many C here, okay, how many C here and how many D here, and then times the IDF. Okay, so that value is this one. This is for the C, this is for the D. Okay, so this is the length of the document that we will be used in here. So now we know the weightage for all the term set that we have in the document, we need to know what is the weightage for the each of the term set in the queue. So this is the calculation for. Let me see. Okay, for this one, we only take the one that not 0. So this is 0. So we only take 1, 2, 3, 4, 5, 6, 7. Okay. So we have to match with the queue. Now we are looking at the queue. So for the weightage for A in Q, so they exist one time, so one time only. And this is the same number that we use for this one. And then if we look at A, B only one, and then D only one. This one you copy from here. And then AB only once. So, okay. And then AD only once. Okay. And BD only once. Okay. And then this one ABD. So we have ABD. So once. Okay. So we compute the weightage. So once we get the weightage for all of this, then we just straightforward plug into the formula. Okay. So according to the formula, we are looking at the vector of the document times the vector of Q. So basically, we just match them lah, and then times and then get the summation. So for that one, so this one will be multiplied with this using the same keyword here, but from different document 1 and Q. We get that one, and then we add up again for this second component, third, fourth, fifth, sixth, and seven. So we have 7 component here. 1, 2, 3, 4, 5, 6, 7. Okay. And remember that this is constant, so we do not have to compute. So that's why in this calculation, they only say divide by the length of the document, because Q will be the same with all the calculation. Okay, so once you get all the number in the right place, we get this one. So this is the distance between document 1 and Q. So if you were to ask to do the ranking, you need to do the similarity between document 2 and Q, and then similarity between document 3 and Q, and then similarity D4 and Q. So you pick because this is similarity, so you pick the highest one. Okay. Okay. Any question? Boleh follow before you boleh.
Boleh, Dokter.
Okay. So we proceed with the next one. A bit more complex, because now what we are looking at is we're looking at the frequent term, kan? So it depends on the frequent term. Then it depends on the threshold. So we limit the number of term that we use. So in this case, we are using 5 term set. Okay, so we have A, B, D, and then A, D, and B, D, and so on. Okay. But in this calculation, basically we use all. We did not remove all the non-frequent. Okay, so if I say, okay, we only compute the one which is frequent. So the one which is frequent will be this only, A, B, D, and then A, D, and B, D. So in this calculation, we will not include this. We will not include uh, the frequent one is AD and BD. So we will not include this one. Okay. So the next stage is okay, closed term set. So closed term set meaning that if you have a set A which is frequent and also set B frequent and also SAB, so that means during the calculation we do not have to include this one because they already covered by this. This is a superset to A and B. Okay, so that is what we say closed term. Uh, this has already covered this. So the closure of A, B is A and B. Okay, so this is the definition here. The closure of term set Si is the set of all frequent term set. So if you have SA and then SB and then SAB, so we do not have to consider this. So by doing that, we have reduced the number of elements that we want to calculate. Okay. So the definition here given the closure of this Si, the largest term set. Okay, the largest term set. So this is the largest term set between these three. Okay, this is what we call closed term set, and it refers us to as this by I. Okay, so we formalize this one. Let di be the subset of C, be the subset of all the documents. So this is the subset of all the document that we have that consists of this term set Si, and let capital letter S di be set composed of the frequent term set that occur in all document di. So meaning that we will take um, all the document that consider in here and whether that document exists in here or not. Okay, let me give you example here. Okay, so this is the definition of closed term set. We say that there is not exist the term set J, which is the subset of this, such that the closure of I is the subset of J. So meaning that this is the maximum one, the maximum term set. So you will not have to have a smaller one. So for example, like this, let's suppose the threshold is 2. So meaning that all of them are frequent. Okay, but since we have for these two, we have 3 documents that has this term set, and then this one is no, yeah. Okay, so for frequent term set B and BD, there are three documents. So since we have 2, so this is frequent, but we only cover the largest term set, so which is this BD lah. So similar to this, so this is A and AD. Both term set A and term set AD has 2 documents each. So we are saying that we just take the largest one. So similar to this, GH, so GHD, so we take the largest one. Okay, so from 1, 2, 3, 4, 5, 6, 7, 8, 9, from 9, we reduce to only 4. So closed term set encapsulates smaller term set occurring in the same set of documents. So this is the closed term set that cover all of this. Okay, so let's take a look at the example here. Okay, now we are looking at document 1 and the queue. Okay, so the content of Q is A, B, D, N, and the content of D1 is A, B, C, A, D, A, D, C, A, B. Okay, so now what we want to do is we want to find the term set. So based on this is what we have before. So what we have before is that we have to look at the document here. So the document here is 2 and 2. Okay, document 1, document 2. Huh? So we take this and combine. Okay, so that's what we get here. Then since this is the largest term set, so we take AD. Okay, and then we look at again for D1, D3, D4. So we have this. Let me change the color. Blue. So we have this document 1, 2, 3, and 4. We also have document 1, 3, 4 here. So we combine. So basically these two. Okay, BD. So BD, we will have B only. We take this one only. Okay. So which one again? We have D4. So now let me change the color. Okay, so we have D4 here. D4, 1, 2, 3. So we have N. No, yeah, N. We have BN. We have BDN. Okay. Then, but so based on this, the largest one will be B, D, N. Okay, but we do not have here because these are not the frequent term set. Okay, let's take a look at the other one, D. So D, okay, for this one we only have one. So just D to D. And also we have this. Let me change the color. So for D1, we have D1 and D1 here. So basically we have this. Okay. So that one is reduced to ABD only. Okay, so for the remaining, this is similar to that, this is similar to this, and this is similar to that. Okay, so basically we have all of this. So now the final term set is only AD, ABD, and then D and BD. Only these four because this is the same. Huh? This is the same. This is the same. And these are the same. So 1, 2, 1, 2, 3, and 4. Okay. Okay. Any question? Okay. So this one we do not include here because in document 1 you do not have BDN, only in the query. Okay. So we do not include this one. So from 3, 3, 4. From 10, we reduce to 10. So from 10, we reduce to 4. Okay. So this is the final term set for this one. Okay. How does the closed term set affect the calculation here is that now since we have this one computing the ranking of document 1 to the query with regard to the query, this one now we can only limit to this only, D, BD, and AD, ABD. So that means in our previous calculation here, let me erase. So now that, let me see. So this is the final terms that we have. So we have D, BD, AD, and ABD. So in the calculation, we can remove this one also. So this is one of them, yes. Let me see. And BDAD, BDAD. So this one we can cancel out. This one is okay. This one is okay. And last one is ABD. Okay. So this one is okay. So we have reduced the number of calculation by removing this, and this one. So we only have this 4. Okay. So the value is smaller here because we have reduced the number of uh, calculation. So it reduced our time of computation. Okay, but still we managed to find the similarity. So this is based on the frequent term set and also based on closed term set. Okay. First, we reduce the number of element by looking at the frequent term set depending on the threshold. And the second one is that we only include the closed term set only. So we will ignore the remaining. Okay. So let's see the second one. This calculation is based on closed term set. But if we limit the frequent term set to a certain number, so for example like this, where's my mouse? Okay, so if the threshold is 2, so meaning that I will not include all the single term. Um, for example like this, I think already shifted here. Okay, so the threshold is 2 here. So the threshold is 2, meaning that we will not include all the x here because they only exist in one document. Why this one is there? Oh, they cannot shift. Let me the third tool. Okay. Okay. So since we are using only threshold 2 equal to 2, so we only take those term set that has more than one document. So this one we will ignore because this term set only exists in one document only. So we ignore this, we ignore that. Then we have these 3 only. Okay. So based on these 3, we find the closed term set again. So um, from this and this, we get this one. And then we have this and this, we get this. And then the next one is D. Okay. So this one is the same. Okay. So at the end of the finding here, we only have 3 term set. So this is based on frequent term set threshold 2, and then we use the closed term set. So again, it will reduce the calculation only 3. So for D, BD, and AD. D, AD, and BD. Okay. So this is based on threshold 2 and also based on closed term set. Okay. That one. Last slide. Thus, if we restrict the ranking competition to closed term set, we can expect the reduction in query time. So less number of calculation lah. But first, you must identify which one is the frequent term set first, and then you further reduce into closed term set. So that's how we reduce the cost of computation. But you need to understand how do you pick the frequent term set. So the frequent term set depends on this. So if given the frequency, the minimum frequency threshold is 2, so we look at this here. So whenever you see single document, you remove them. Okay, you remove all of them. Then after that, you list out all the same document that we have here. Then we take the larger term set, which is this one. So if we have this one and this one, the larger term set is this. And this one only one, so we just take itself. So we have 3. Okay. So don't worry, you will have the assignment already. So if we look at the assignment, let me. Okay, so if I share this one, can you see? Can you see the question? Okay, so di sini diberi the same document again. So given the above document, compute the ranking similarity between D1 and Q of document 1 with regard to the query ABC. So your query now is ABC with minimum frequency threshold 2. So the first thing that you need to do is you need to list all the possible term set that you have. So the possible term set that you have will be A, B, and A, and then B, and then C, and then AB, AC, and then BC, and then ABC. Okay, so you list all the document that consists this term set. Then after that, you will, depending on the frequency of the term set. So in here we say at least two documents. So you will reduce, and then after that you will find the closed term set, and then you can compute the weightage. Then use the cosine to find the distance. Okay, so you understand the question now. This is similar to the one in the slide, but I changed the query ABC. So in the slide here, the query is different. Okay, so the query here is this one. In the exercise, the query is ABC. Okay, so you need to list all these possible term set first. So meaning that you have SA, and then SB, and then SC, then SAB, SAC, and then SBC, and then SABC. Then you construct this one lah. So depending on the number of document here, some may be removed. So we use the same threshold here, so you may have this one. Okay. So any question?
Format apa kita menghantarnya?
Normally you just save as PDF and then you just submit lah in the end. Word pun boleh juga. So you type the solution or you write the solution. Ada juga yang hantar gambar. Dia tulis pakai pensel, lepas tu gambar, lepas tu submit. Itu saja lah. Okay. Any question? Pagi-pagi sudah 1
So
hour.
far,
What?
so far okay.
So
Tapi
far.
boleh resubmit kan doktor? Mana tahu salah.
Yeah. If you want to resubmit before the due date, then you just let me know. Then I just reopen again lah. Kalau you already submitted kan, so you just WhatsApp me. You want to resubmit, then I will reopen the submission lah.
Okay.
Okay. I think that's all for this morning. Hopefully not too heavy. Okay. Para tertinggal sudah, tapi tiap habis sudah. So I just stop the recording.